In this part of the product tour, we'll take a closer look at the top-down strategy for modeling and developing a new process orchestration. Using this strategy, a business analyst or developer can sketch out the business process at a high level in terms of general tasks and overall process flow. Then, add more granular information like service and message definitions at a later time. Today I'll be working from the BPMN editing style, which is the default editing style for ActiveVOS 7. Existing ActiveVOS customers who might prefer our classic presentation can change the default editing style in the Preferences menu. First, I'll create a new process by right-clicking on the Beeple folder in the Project Explorer view and select New Beeple Process. I'll give the process a name and select Finish. I'm presented with a blank canvas and can now begin sketching out my process by dragging objects from the palette to the canvas. The palette is divided into sections called drawers. Activities represent a single unit of work within the process, like a task performed by a person, invoking a service, or mapping message data. I can define events in the process, like the start and end of a process, when a message is received or sent, and I can also define alarms, errors, compensation events, and define other events like the need to break out of a loop. The control flow drawer lets me define loops and branching logic, and also group activities into logical units of work called scopes. Event handlers let you define what should happen when a certain event occurs, like an error is caught or an alarm is triggered. And you can add labels and shapes to your model to make it more readable. Let's get started. Typically, processes begin when a message is received, so I'll drag a receive event to the canvas and rename it to receive quote request. Let's say the first thing I want to do is invoke a service to validate the request. I'll just drop an invoke activity right below the start event. By dropping the activity here, a sequence is automatically created and a link is drawn. Now I'll just click on the activity name and give it something a little more meaningful. Now let's say we want to insert a simple conditional branch based on whether or not the request was valid. I can drag an if statement to the canvas, and maybe change the default labels. Now it's just a matter of dropping in the activities or events that should execute for each conditional path. And now I'll add an end event to complete this sample process. A fork join can be used to execute more than one path simultaneously. Now I can simply drag and drop activities and events into each of the paths. Let's get rid of the fork join we just put in. I'll select the group on the canvas and hit the delete key. Loops and scopes can sort of be thought of as an embedded sub-process, and they're drawn that way on the canvas with a border, a start event, and an end event. So again, now it's just a matter of dropping in activities between the start and end events. Bordered activities like this scope can be resized, and additional events, activities, and event handlers can be added. For instance, I can add an event handler for when a wait alarm fires. When I'm done working on the activities within this scope, I can save a little real estate on my canvas by collapsing the scope container. Finally, as I mentioned earlier, we can add labels and shapes to the diagram to make it more readable. Let's add a title to the process. If you prefer looking at the process flow from left to right instead of top to bottom, you can right-click and change the orientation. The default orientation can also be set in the preferences. Let's take a look at a more complete process, the quote process, which is included as part of our classic cars demo. This process was modeled using the same techniques that we just reviewed. The process begins with a message being received. A service is called to validate the request. An if statement was used to control the process flow based on whether or not the request was valid. An invalid request results in an error message being returned, and the process ends. If the request was valid, the process flows down this path where an acknowledgement is returned and an email is automatically generated and sent to the customer. This next block of activities was grouped together as a scope, which again can be thought of as sort of an embedded sub-process. We could expand the contents of the scope using the right mouse and expand container, or we could expand it by simply clicking on the plus sign. The first activity invokes a sub-process where the estimate is calculated. We'll take a look at this sub-process in a minute. Next, an assign activity shows us that a change in status is being recorded. This intermediate message event depicts the response message being returned from the sub-process. The status of the process is updated again. An email with the final quote is sent to the customer. In our business scenario, if a quote is not accepted within 3 days, it will expire. We're using a timer to keep the status of this request as running for the life of the quote. After 3 days, the alarm event will fire, and this logic will be executed. During the life of the quote, the customer can submit a request to view the status of the order. And of course, we need to handle errors that may occur at any point within the scope, which are described here. Now let's take a look at the estimation sub-process. You'll notice that this process looks a bit different than the quote process. We start off with a basic sequence of activities, as you've already seen, but instead of using a conditional branch like an if statement or a fork join, this process uses an inclusive gateway to control the process flow. An inclusive gateway can handle multiple true paths. So, for instance, in this process, when the request is initially reviewed, the chief mechanic either completes the estimate himself or can delegate the estimation work to any or all of the specialists that are on staff. If he decides to delegate work to the specialists, the process can fork into as many as 3 paths, which would all be executed in parallel. When each of the paths are completed, the process will resume and the chief will put together the final quote for the customer. So let me show you how we accomplish this type of a pattern. Let's go back to our test process from before so we can play around. I'll put down a receive, a reply, and a gateway. And these activities are linked together in a regular sequence, as we've already done. First, let's change the gateway to an inclusive gateway, which basically means that more than one conditional branch can be true. I'll place a few invoke activities on the canvas, but I'll place them outside the boundary of the sequence. To connect the gateway to the activities, I'll select the link tool from the palette, then just draw the lines from one activity to the next. Now if I select one of the links, you'll see in the property sheet that I can give the link a name and provide an expression for the condition. And now I'll add another inclusive gateway and connect each of the activities to the gateway. This second gateway will basically force the process to wait for all upstream activities to complete before continuing. And at this point, I would just add in the rest of my process logic as needed. So now you have a basic understanding of how easy it can be for business analysts or application architects to use a top-down strategy to design business processes that incorporate both human activities and web services. In the next vignette, you'll see how a developer can add service definitions and implementation details to make the process executable. Thank you.